Hi, Stefan here again, ready to continue with part 1 proper of our tutorial series on creating a game in Codeskulptor. A platform game, so hopefully going slightly beyond some of the stuff we learned in the class, building on what we've learned and hopefully taking it somewhere interesting. If you remember, if you watched the last video, before we begin coding anything, we're going to just take a look at some classes and some class anatomy, and we're going to look at art assets and sound, where to source them and that kind of thing. So I have downloaded a PNG file which contains tiles for backgrounds, and I'm gonna create a background class and display it on screen, and it's going to be choosing tiled images from this image and displaying them on the screen. So it helps to think of this image each as having sub images, and each of those having coordinates very similar to coordinates in lists that you might have seen in Python. So for instance, if we look at this square here, this will be 1, 1 because it's 0, 1 along and then 0, 1 down. Initially I'm just going to draw our background using this block here, which is at position 0, 1, and I'm just going to draw a flat surface at the bottom, and then we'll get that moving. We'll move the camera and we'll see how moving the camera moves us along the background. And that might be about all we get to today. Beyond that, we're going to look at drawing a character on there and making sure collisions work, so he can run along, he can jump, but he can't fall through, and so on. Okay, so we just need to know with this image the coordinates. If I look down here, this is paint.net, which is, I think, fantastic free video image editing software, image editing software. It does things like transparencies, which are very important for video games. If we look at this block here, we'll see the center position should be 1648, and it is about 1648 roughly, and the size should be, it's about 30. Let's take a look at the size, and what I'm going to do is I'm going to draw a box around what we want and just make sure we get the right sizes. So the image is 250 by 250. And our selection here is telling me it's 31 by 32. I imagine it's probably should be probably should be 32 by 32, and I think that seems likely that the sizes of each of the blocks is 32 by 32. Okay, so before we get started, I just want to look at, there's a couple of kind of supporting classes that I want to make here. The first one is a class I like to call var, and that var is for variables. A little differently to some of the classes you might have seen in class, as it were. This var, these variables are static, so they don't require an instance of the class var to be created, and essentially you can use them like global variables. They just give a scope to variables, and there's no confusion. If we create a variable called x, you might see variables called x everywhere. These variables will be var.x, so there's no potential confusion as to what they are. So I'm going to start off by just creating a canvas width and height, 800 by 600 I'm going to go for just now. I might rethink that in a minute. Actually, do you know, I'm going to drop it to 600 by 400 just for performance reasons, and then we can always go up. One other thing that I like to do is to give a kind of old school pixelated feel to games. I'm gonna scale the graphics. I'm going to scale by 2 initially, and I might take that up or down depending on how they look. And essentially what it's saying is for our source graphics, for every 1 pixel, we're going to draw it as 2 by 2 pixels on the screen. So we're kind of scaling up, and it gives it an older kind of look. Plus has the advantage that the graphics are smaller, so they load quicker. And just for the purposes of the kind of games we're building, I think it's kind of appropriate to have that retro look. Okay, so I'm going to have our tiled graphic for the background, tiled image I'm going to call it, and it's simple GUI load image, and then I'm going to get my Dropbox URL and put that in there. Just one thing I obviously need to do before this is my imports, and I'm just going to do the usual math, simple GUI, and random. Can't go wrong with those 3. Just a word about IDEs and editors. Whatever works for you is great. I don't tend to write stuff in Codeskulptor because I write a lot of code. Some of my stuff is like 1,000 lines long, and if you've typed 100 lines, getting 100 lines of good code is really difficult enough. If you've typed them and then you accidentally close the browser tab, it's absolutely infuriating. So just a few advantages that I think of IDEs generally are things like autocomplete, color coding, the ability to automatically save. If I work on stuff in work and at home, both in Visual Studio, it will tell me if I leave a file open in one of them. So I like Visual Studio for that reason, but obviously whatever works for you is great. So we said that the tile size in that image that we had, a 32 by 32. The reason I'm not typing, I'm going to keep this as a variable and not type it in, is that we might go back and use a different tile set at some stage, and then we can just edit the numbers here. We don't have to go into. Plus there's this concept of magic numbers. If you pepper your code with numbers with no explanations, it can just make it a little bit more difficult to troubleshoot, to figure out when something goes wrong, because you're looking at a number 32 and it could be, you know, is it 32 pixels, is it, you know, where does that 32 come from? So this, at least we know this is the size of our tile, and the fact that it's next to tiled image kind of gives a clue that it's the size of the tiles in that tiled image. Okay, and we're going to be using a camera. There's our character is going to be running from left to right across the screen, and when he gets a certain amount of way across the screen, the camera is going to scroll along and the background's going to scroll and stuff. So the camera, it for now, is just going to be a simple X value. It's going to start when it's 0, the left hand side of the screen is 0. When the whole camera has moved 1 screen width, the camera will be width, which at the moment is 600. And that means the left hand side of the screen will be essentially at position 600. So what we'll do is when we're determining where to draw something on the screen, we're just going to essentially subtract the camera from the X value. Okay, so far so good. Now, like I say, that's a class that doesn't get instantiated and has no methods at the moment. We could create static methods for it. There's never going to be an instance of the var class, but it's just there to, at the moment, to hold our variables, and there might be some static methods that we want to declare for it as well. Okay, so and then what we really want to do now is create a background. So this is going to be extend. It's going to start off just drawing some blocks, basically blocks at the bottom of the screen that are protagonist is going to run along, and when he jumps there's going to be collision with the blocks, so when he jumps he'll be in the air and then he'll fall, and when he comes in contact with the blocks again he has to stop and run along them. So so we need to decide the height of the screen is 400, the size of the blocks is 32 times the scale, which is 64. So 400 divided by 64, let me get my calculator out. It's 3216, it's 100 divided by 16, isn't it, which is about 6. So it's only going to be 6 blocks up and down the screen. Doesn't seem like a lot. I'm gonna make height 600, and that will make 9 blocks. So sorry, 600. So the reason I'm asking that is we need to create a size for the. So the background class is going to be instantiated. So there's going to be an instance of the background class created. I'm going to just give it a default size. So I want it to be about 5 screens wide for now. We can work on. We can increase that, change it at some later date. But just for now, we want 5 screens, which will be 3000 divided by the tile size is about 32 times 2. So 3000 divided by 30 is 100 divided by 2 is about 50. So in the X direction we want about 50 blocks, and then we said Y 9 blocks should fit nicely on the screen. Okay. So self.size, we're going to say size, aren't we? Just a note about when this goes in and we run it, it's not going to work, and that's just the way it goes. This is something I'm resigned to, that when I first type and write code, it never works, and it's the process of debugging during which I learn how things actually work, and that's my process anyway. So okay, so we also need somewhere to store the blocks, the individual block. I'm going to call them self.bricks, I think. Okay, and that's going to be a list. It's going to be a list of lists, and it's going to be an X and a Y list of lists. Now the way we make a list of lists size X and Y, we say for X in range size 0. Now we can just say size 0. We don't need background.size0 or self.size0 because we're still in the constructor. So size is declared here, and we're going to self.bricks.append an empty list. So we get an array of size X that's just array, and a list of size X that's just empty lists. And then for Y in range size 1, we want to append to self.bricks.x, we want to append. You see, actually there, see, autocomplete came up with append, as it gives me the list methods here: pop and append and insert and remove and so on, sort. So I know this is a list, and it knows that this is a list because we've just appended lists, and we're now going in indexing inside, and it's smart enough to realize what the data type of that must be. So what we're going to append here, we're going to append a set of coordinates that basically tell us the position within our tiled graphic for the brick that we're going to use. So I said it was 0, 1. Let's have a look at that and just confirm that. So here is our background and there's our graphic there, and we said it's 0 along and 1 down. Remember, in computer indexing we always start at 0, and so that's 0, 1. Okay, now I don't want every single block to be that 0, 1. I want some of the blocks to be empty. So for empty blocks, I'm going to use -1, -1. So this basically is indexing off the sprite sheet. And what I'm going to do, I'm going to put a test now. I'm going to say if y is greater than a certain number. So if we're further down the screen than a certain amount, then so that means that we just get our last couple of. So if y is greater than or equal to 8, so if y is either 8 or 9, we're going to put our block, and then otherwise we're going to just append a blank block. Okay. And the other thing the background has to have is a draw method. It has to have a way of drawing itself, so we're going to just define that. This is going to be called from the main draw method that we define. And we basically want to go through every block. So for x in range, self.size, and now we have to say self.size 0 because we're no longer in the constructor. And then for y in range, self.size 1. So for each x and y in this list of lists, we're going to draw the block. So canvas.draw_image, and you maybe just remember the 5 parameters that draw image takes. It takes the image first of all. Now we said that was called tiled_image, so it's var.tiled_image, because if you remember, we declared it in our static. It's a class variable for the class var. So tiled image is 1, and then it's going to be the rest are pairs, so either tuples or lists. I'll put them as lists. It's quite interesting to look at the difference between tuples and lists. One of the differences is that tuples are hashable. So if you create a dictionary, you can't have lists as the key values. So if you come to making dictionaries using pairs of coordinates, you actually have to use a tuple. Fun fact there. So the 4 numerical parameters are the source center. Now we said that is what we're essentially appending here. 0, 0, 1. This is the center coordinates from the source. So we're going to say self.bricks 0, comma self.bricks 1, and of course it's not that simple. What we need to do is we need to multiply it by the size of a block, and then add half a block, because we need to get the middle. It's the middle coordinates of the block that we're getting. So self.bricks 0 times, and the block size we have here, it's var.tilesize 0. Now you're probably saying, but Steph, var.tilesize 0 and var.tilesize 1 are the same, so it doesn't matter which you use here. But if we choose irregular sized blocks, rectangular blocks for a later level in our game, that will break our game code. So we have to use tile size did that var.tile size? Yeah, that's okay. Okay, yes, no equal sign there. I wondered why autocomplete didn't work. Actually, do you know it's a bad sign when autocomplete doesn't work. It usually means there's something wrong. It's that good usually that you can tell there's something wrong in your code if it's not working. Okay, so this is going to be kind of essentially mirrored here. Self.bricks, except these are all going to be 1s. Tile size 1, self.bricks 1. Now that's self.bricks0 and self.bricks1. Actually, it's self.bricks x, y 0 and self.bricks x, y 1. We can see that our line starts to get, I mean, I'm not nearly finished with this line and it's starting to look complicated already, but I think it's important that we can handle a bit of complexity. It's good to try and stay ordered, but stuff will naturally get complex and not necessarily difficult, but can take some picking through and being methodical. And I don't think we should be scared of that complexity. And quite often I find myself writing stuff that I don't even particularly understand on the first go. I think that's okay too, I think. Okay, so getting back to our 4 numerical parameters for draw image, they're the source center and then the source size, which is, as we know, just var.tilesize, the source size. And then I'm gonna give us a new line here, and then it's the destination center. Now, if you think about the destination center, they're really given, it's dictated by this x and y that we've set up here, for x in range, for y in range, minus the camera for x minus camera and y. Now it's not, again, not that simple. It's actually x times the scale times the tile size zero and then plus half a tile. Now actually the way I like to do this is to say x plus a half times scale times var. So then now that actually, and this is something to be aware of more so in other languages, that turns all of this into a float from an int. Now that would be a problem in some languages. In Python Codeskulptor it actually is okay. So it's the same again, but there's no y component to the camera, if you remember, so we're just going to say use that and just change y, and we're going to change this to tile size 1. So that's the destination center point that we're going to draw it at. And then the size at the destination is going to be the tile size scaled up. So it's got tile size times var dot scale 0. That's tile size 0 times var dot scale. There is no var dot scale 0, and then tile size 1 times var dot scale. Okay. Now, what else do we need really? We need to set up our frame. So I'm gonna use 2 classes here. One called program is going to be for game logic. Actually, do you know what? I'm going to call that game. One called game is going to be for game logic. And part of game logic is holding instances, excuse me, of the character, and in this case the background. And then another class called GUI, and that's going to hold our frame object. Frame equals simple, I can never remember the simple GUI dot create underscore frame. Need to give it a title, platformer, and then the sizes are going to be var dot width and var dot height. Okay. We're also going to need, the GUI class is going to have our main draw method, and this is where the magic happens. You know, this draw method is going to get called every 16 milliseconds, 60 times a second, every 16 milliseconds, and really we're going to use it to synchronize and to run everything. Every cycle through is a cycle of this draw class. So what we're gonna call the program dot background, which is the instance of the background class we just created, dot draw, and that takes a canvas. It takes 2 parameters if you see self and canvas. The self is class.background.draw. Okay, it's not program, I called it game, didn't I? Game.background.draw canvas. Again, autocomplete didn't work, but that's how I knew that was a problem. And then we just need to start our frame, essentially. So we say GUI.frame, set draw handler, and it's GUI.draw, and then GUI.frame.start. Okay. So I need to get a Codeskulptor window open, which I have here. Close down my perfume shopping that I was doing. And I'm going to select or copy this, and like I say, it really is not going to run. That's just the way it goes. Okay. Okay, so I'm gonna troubleshoot this in Codeskulptor because because it's easier to do that and then copy it back. We can quickly press run. This is fairly obvious. 4 in range should be 4x in range because we're setting up x. Okay, and the scale is not defined. That should be var.scale. So wherever I've got just scale on its own, let's see, var.scale, scale, there it is. So var.scale, and I can see a camera sitting there on its own. That not using globals makes it much easier to debug. You can see immediately that this is camera can't be right for where in a draw class. If it said canvas, fair enough, but you're not being passed the camera parameter. So and there we go, and it's drawn a single line of those blocks. Now we can just a little proof of concept here. In the draw handler here, I'm going to increase the camera X position by 1 every frame, and so we should see some movement. It's 1 pixel, that is, every frame. So 600 seconds to get across the screen. It's not going to be moving fast. Actually, let's up that to like 3 or something. So, and then we should see some scrolling. And we didn't. That's because it's equals plus and not plus equals, maybe. And there we go. So there we see some scrolling. And this is we're gonna get it's just gonna go off the edge, I think, eventually. Okay. Can you imagine a player running along here, and then lots of stuff going on in the background, and universal acclaim. You can imagine that as well. This actually is too low, I think. Also, the size of the blocks is not right, or the size of the screen. This should be 8. This should be 10. So the blocks should go off the screen. Let's just have a look at that again. Yeah, there you go. That's more like it. So there's one other thing I want to do. We're drawing every single block in that array, in that 50 by 10 array, so all 500 blocks every frame. But most of them are not on the screen. So we're just going to put a test in here. If the camera is less than the X position, but we want the X position where it is drawn. So it's the X position times the scale times the tile size, and that itself is less than var.camera plus the width of the screen, which is like saying the right hand side of the screen. So basically, if the X position of the block is between the left side of the screen and the right side of the screen, that means it's in the drawing area, then we're going to draw it. And by implication, we're not going to draw it if it's not in that. So let's see that again. It should look a little bit smoother. The other thing is it's now chopping off blocks at this end. Now the way we do that is we say we take half a block off of this camera. So we move the left hand side of the screen that it's using by probably by a block, which is var.scale times var.tile size 0. So we're going to say camera plus that is less than, and now you should see it's even worse. I think that's camera minus a block, so we're moving it left, of course. So there we go. Now the tiles aren't being cut off, and that's working, and we can use camera updates. So just a little recap. What have we got? We've got 1, 2, 3, 4 classes, and we've got our background up and running. Next time, we're only really at generate and display background here. Steps 1 and 2 in our process. We're going to look at the camera next. Look at the character next. Just getting them drawn on the screen, animation, moving them, collisions. Okay, thank you for watching.